Hi and welcome back to Geology. This is Miss Sparks. Previously we've been talking about our plate tectonics and we got about halfway through our convergent boundary. So we talked about divergent boundaries in which you can have either a rift valley, which is above sea level where the plates are being pulled apart, or a ridge, which is below sea level, which is just the plates are being pulled apart. Our second boundary that we've been talking about is our convergent boundaries, and this is where plates are being pushed together. And we can have three different types. We can have oceanic, which causes a trench, two heavy plates colliding and dipping down. We can have oceanic continental. When they run together, the oceanic plate subducts underneath the continental plate to create volcanoes as a result. And then finally, our last one is continental. And this is when two lighter continental plates come together, and as they do that, they get thrusted and pushed upwards, creating what we call folded mountains, which just means that the waves or the sediments of those materials, when we look at them, almost look like wavy-like, and so that's called a folded mountain. And so here's an example: continental crust, and we have a mountain range. Mount Everest is a great example of this. The Rocky Mountains are a good example of this. The the Andes Mountains in South America are a great example of continental crust being pushed together to create these folded mountains. Our last plate boundary is what we call a transform boundary, and this is where two plates are just going to slide past each other. And so as a result of this, we get faults and earthquakes. And so the best known example of this one is the San Andreas Fault, which is out in California. It's actually, a lot of it is cut right through the city of San Francisco. And so once again, these plates are sliding past each other. So there's always a myth that one day California is just going to have such a big earthquake that it's going to actually fall into the ocean. It's actually untrue. California sits on the Pacific Ocean plate, while the rest of, or parts of California and the rest of the country sits on the North American plate, and they're just slowly sliding past each other. So at one point, California will end up closer to Alaska. So once again, that's our transform. Here's a picture of it. So we've got the fault running right through here. And once again, we have the North American plate, ironically, is moving south, and the Pacific plate is pushing north. So technically, this guy is moving this way, and North America is slowly ticking down this way. And you can actually see the fault from an aerial view. So let's talk about some causes of plate tectonics. What are some things that are a result of the process of these plates pushing and pulling into each other? So all these forces that are happening. The first is the convection currents that are occurring in the asthenosphere. These convection currents are the driving force that causes the plates to move. So that convection that is happening is going to pull and push and all kinds of different things with the plates. So hot magma in the earth moves towards the surface, cools and sinks again. And that's just convection. Warming up, cooling, sinking. This is our fundamental thermodynamics. So it creates convection currents beneath the plates that allows them to move. So you have a tug or a push on those plates. And so as you can see, you have here's our asthenosphere, and we have these circular motions. This represents our convection currents. So this one, if the magma is moving this way, it's going to pull that plate with it. If it's moving this way, it's going to pull the plate moving that way. So as you can see here, we got a ridge or a rift, our divergent boundary, and then we have two plates coming into each other, forming a trench and some subduction. So hopefully that was a little bit helpful. We're going to also talk about what these boundaries look like, kind of get used to my drawings with them, and then kind of really focus and put them all together. So hopefully this was helpful.